All right, so now we are going to still apply the same machinery, differential and linear approximation, stuff like that. But we will use these tools to solve um, an applied problem, right? So a word problem. So here we have a closed rectangular box with a square base of side 3 and height 5, right? So it looks like this, basically. So this is our square, and it's probably a bit taller than it is wide. So something like this, right? So the dimensions of the box are 3 by 3 by 5. If the side is measured with an error at most 0.02 units, right? So here plus 0.02, and the height is measured with an error at most 0.01, so plus minus 0.01 units. So use differentials to estimate the maximum possible error in computing the volume of the box, right? So um, the setup here is that generally speaking, we have a box uh, with a square base, right? So we can safely assume that the dimensions of the box are x by, let's say, the height of the box is going to be y. And the volume of this box, say v, as a function of x and y, is going to be, well, x times y is going to be x squared y. All right, so these errors, 0.02 and 0.01, I mean, so they could be positive or negative, right? So, but essentially, um, you know, it seems like, if you uh, underestimate so the actual dimensions. So if the actual dimensions are bigger, then of course the volume is going to be bigger, right? So we can just use the positive signs everywhere. So all right. So what I'm trying to say is that delta x is 0.02. Well, I mean, let's say maximum delta x. Strictly speaking, it's absolute value of delta x. So delta x could be also negative. So the maximum delta y is 0.01. Right. So what is going to be the error in the v? So the estimated error is dv is going to be, well, generally speaking, is the partial derivative of v with respect to x times delta x plus the partial derivative of v with respect to y times delta y. Now, again, so we want to get the maximum possible error. So hypothetically, if this were negative, so then to get the maximum error, so we should use the negative value for delta. We should have used the negative value of x for the to estimate the error. Yeah, but here everything is positive, so I'm not really going to pay attention to the negative signs here, right? So partial derivative of v with respect to x. Well, let me write it here. So partial derivative of v with respect to x is what is 2xy. Partial derivative of v with respect to y is x squared. Okay, so let's just substitute. So 2xy. Now my x is 3 and my y is really 5. So 2xy is 2 times 3 times 5 is 30. 30 times delta x is 0.02. So again, so if hypothetically, if partial derivative with respect to x were negative, then in order to get the maximum possible number here, I should have used negative 0.02 instead, right? So plus um, partial derivative with respect to y is x squared. My x is 3, so it's 9 times 0.01 unit, and I guess this is just 0.69. That's the answer.